Hi, I got a world exclusive for you. Check this one out. Well, it's not actually this one. This is the Rigol MSO5000 series scope, which I've done a extensive teardown of and a first impressions unboxing review on the second channel as well. I'll link that in if you haven't seen it. And this was released in June, I think it was, and it uses Rigol's new ASIC technology. They're one of the big players now with their new Phoenix chipset and their own front-end chipset, which they rolled. And this is, it's quite impressive scope. Unfortunately, it comes at an equally impressive price. And from what I'm hearing, it's not exactly a big seller because it's trying to compete at the real sort of middle into high end of the market. And it's, bang per buck doesn't seem to match it. And I was saying in the video, well, this is their first scope which uses the new Phoenix chipset. They're probably getting back the year's worth of NRE on these new ASIC chipsets. They've been working on them for a long time. As impressive as it was, it just wasn't that polished yet. And I said, well, look, I'd love to see this in a lower priced scope. And I thought, hey, this would be like a year, at least 2 years away, perhaps, something like that. But no, thank you very much to John South at Emona here in Sydney. I've got the only one in the country. Check it out. I was shocked. This is being released in a couple of days' time, but we're going to take a teardown look at this. This is the new Rigol MSO5000 series, the MSO5354 digital scope to be precise, and it uses a new Phoenix technology chipset. I can't believe it's been like 5 months and they've released a new lower cost scope. How low cost we're talking about? Well, technically it's under $1,000 Yankee bucks, $999 US dollars base price for a 2-channel version, and we'll get into this. 70 megahertz bandwidth. I don't know why they bother with the 70 megahertz bandwidth instead of 100, but it comes in 70, 100, 200, and the one we've got here is the 350 megahertz, 8 gig samples per second. 4-channel scope with MSO capability. Very nice. It starts from $999, but it goes up reasonably pricey once you option up everything in this, because everything is optional extra. We've got our 4 channels, 2 channels are optional extra, and we've got our 2-channel arbitrary function generator, and it's got touchy-feely screen, but still, it's under $1,000. So they're leveraging that new Phoenix technology chipset and also the front-end chipset. They'd be using the same one, but in this case, the bandwidth is limited to 350 megahertz as opposed to 500 in the other one. And you'll have to excuse any issues with the quality of this video. I am shooting it in the new lab, and I don't have any of the new lighting installed or anything like that. So yeah, we're just going to have to get what we get. A little bit shorter than the 7000 series. The 7000 is a little bit taller and it's a little bit thinner, not as boxy on the back. And as you can see, it's black instead of white. Now, whether or not you like black, I don't know. It seems to be a trend these days. Whatever. Anyway, the new one doesn't have the x10 probe interface and auto probe interface and powered probe interface that the 7000 Series 1 has, and you probably wouldn't expect it, certainly wouldn't expect it for a sub $1,000 scope, although it kind of would have been nice to at least have x10 probe detection, even if you couldn't power external active FET probes and stuff like that. And unfortunately, when you option this fully up, you get to a different price bracket, and then you start to think, well, I'm paying all this money and I can't even detect my probes. Not great. Starting at 909 Yankee bucks for the 70 megahertz version with no software options, and that's only the 2-channel, or 999 with the 4-channel. So I don't know why you would bother even buying a 2-channel version of this. It's just crazy, because this is the interesting thing about this new 5000. As far as I'm aware, it's the only scope on the market that actually comes with 4 channels, physical 4 channels. It's a software upgrade to the 4 channels. And if you buy the 2-channel version and want to upgrade to the 4 channels later, it's $399. Whereas it's only 90 bucks if you buy it up front. Nuts. Why do they even bother? Unbelievable. But if you want the 350 megahertz version we're talking about here, with no software options at all, 4 channels, $4,000 US. So yeah, it's pretty pricey. For the 200 megahertz version, it's $2,700 US. For the 100 megahertz version, it's $1,400, just over. So when you include some basic serial options and stuff like that, and a 350 megahertz bandwidth with the 4 channels, this can be a $5,000 US scope. Now, both of them have the 2-channel arbitrary waveform generator. I believe they're the same specs. Don't quote me on that. A couple of more extra USB ports over here, only the single one here. The logic analyzer interface is different. They've got the 40-odd way 0.1 inch traditional pin header here, which is great for, do-it-yourself custom probes and things like that. But this one uses the little PCI interface. So yeah, they're totally using different probes for this thing. Unfortunately, I wasn't supplied the logic analyzer probes with this, and I don't know why. And it's a similar sort of interface here, except on the 7000 you get the 2 extra waveform controls here, which you don't get on the 5000 series. And of course, one of my complaints about the 7000 series was just the interface and how it looked like it was designed by some, hobbyist or something. It was absolutely terrible. It used, I think, somebody counted 5 different fonts on there, and this one isn't much better. Now, the layout's okay. I don't really have an issue with it as such, but I just don't like the fonts and the colors and the styling. I know it's subjective, but it just looks really Mickey Mouse amateur compared to some of the more professional brand scopes on the market. I think they need to get their act together here. Hire a professional industrial designer who knows what they're doing. See this G1 and G2 here? I swear it's got to be a different font to the others, but I'm not sure. Anyway, like the styling down here, you can't even read. There is a G1 and G2 down there. Like, if you get it in the right light, like that, you can see it, but if it's just down like that and you're looking at it, you can barely see that on camera. I can't see that with my eyes. It's sort of all obscured, and just small things like no consistency in their sort of like font usage, right? Digital oscilloscope all uppercase, the 7000 lowercase. What? So the back of this thing, got our carry handle, which it's not great, doesn't have like a big cutout to get it up. Anyway, it looks a little bit different to the 5000 series scope. It's not all metal work, like coming right out to the back, like we saw in the 7000 series, so it looks significantly different. There's no dust grills or anything that we saw on the 7000, but it does come standard with HDMI output, fantastic USB device, and LXI LAN interface for web configuration and stuff like that, and it does have an external trigger out. Unfortunately, there's no external trigger in like we got on the 7000. And the 5000 has your more traditional feet on the front as opposed to the feet on the back on the 7000, so that's all right. So overall, I know it's personal taste, but I am not a fan of the black. Check out the red identifiers on the knobs there. I'm not a fan of that. They couldn't even, they've got the correct color coding around here, which matches, and we've got all separate vertical controls. Absolutely fantastic to fit that on a relatively compact scope like this one. So that's very welcome compared to like your more traditional compact scope with your shared channels. And yes, all the knobs are pushable. And for those curious, there it is compared to the 1054Z. So to give you an idea, it is, slightly bigger, but considering that they, it's got a bigger touchscreen and they've put 4-channel controls on there, I think it's, about as compact as you can make it, I suspect. But, if you're after the most compact scope for your bench, then, obviously, but it's not that big though. Enough yapping, let's get in there. Looks like we've got 6 screws on the top. They're serious. All right, here we go. Ta-da! We've got, it's much less metal work in it than the previous one. Is this a bit different? Look, tiny little, heat sinks poking out of the can there for the front end. So that's interesting. They haven't fully shielded that front end. Fascinating. Anyway, the fan is right on top. Look at that. It's right on top of the big ass heatsink for the ADC and the Phoenix chipset. Then we've got another heatsink poking out here. So yeah, it definitely isn't as well shielded as the other. I'm sure it's, you know, adequate, passes all the requisite standards. Got our nice mains earth connection going over to there. That's very nice. We've got a real clunking power switch. Yeah, thank you very much. None of that soft button rubbish. Okay, so I rather like this. It all comes get rid of all the cables like this, and this should just lift off. You shouldn't have to take out the power supply. We'll have a squiz at that later. Ta-da! We're in like Flynn. Check it out. And what is that? That is that's the code name, because we had the Flamingo was the previous code name for the MSO5000. So this one's the Eagle, I guess. Rigol, innovation or nothing. Nothing with a lowercase n. Okay, just have a look at our main board here. First thing I notice is, look at the grounding around here, the signal generator section. Look, somebody was having fun. Oh, they didn't go all the way with LBJ. They just went over to there. Meh. Anyway, as you can see, it's not a huge amount in here. It's going to be very similar to the 7000. Well, this is interesting. It's actually a near identical layout to the 7000, not quite a few differences. Anyway, we've got our main applications processor here. We've got our secondary Spartan 6 FPGA up there. This layout here for this looks absolute, for the processor here, applications processor looks identical. There's even all the stuff around here. The battery is a different horizontal instead of vertical, but apart from that, these chip placements are all the same. That connector up there is the same. The power supplies are different around this area here. Like there's much less, or actually, no, look, they don't have the big ass inductors, so they've got smaller ones. So they don't need as much grunt. Is that like because it's not as fast as the other one? It's not chewing as much power. This is 8 gig samples per second versus 10 gig samples per second. They've still got 2 big ass inductor ones here, but as you can see, power supplies are a little bit smaller. They just don't have the same, they've got the SMD, small SMD inductors instead of the large SMD inductors. Anyway, apart from that, it is very similar. We've got we've got an additional relay here on the 5000 for the signal generator part. So that's been it's kind of a similar configuration, but it has been changed, and they've added an extra relay down there. Of course, the digital connector has changed down here, but yeah, digital looks a little bit different. They've got some stuff around here which is the same. I believe that was voltage regulation for the front ends, was it? And of course, the front end cans are different. We've got the heatsink on the chip, which we didn't have previously. And this is interesting. Does that mean that they goofed on the 7000? So maybe they've realized, oh yeah, we better put a heatsink on those. This is 350 megahertz as opposed to 500. And presumably they would be using their same front-end ASIC because they want to, capitalize on that cost, because that ASIC had cost them bugger all now that they've done all the, spent all the NRE money, the non-recurring engineering, to actually design and mask out that thing and everything else. We've got 5 memory. I think we had some additional memory on the bottom. This one is 100 meg samples memory as opposed to 500 meg samples. It's labeled up there, look at that. Spartan 6, lovely. Where's our debug serial header that we saw before? Let's go and check our clock generation down here. I'm liking the look of that. Well, that's pretty funky, isn't it? Sorry if there's any noise on this. As I said, don't have a huge amount of light here, but that's our PLL gen. So there's our memory. Nothing much doing there, but oh, interesting looking termination they got there. Sweet. Looks like they were supposed to have some sort of ESD protection there for the probe compensation pins, but they went, nah, bugger that. Goldfinger. What is Goldfinger? I'm suspecting that might be our UART interface, where we can start hacking this thing maybe. And we've got our same hardware version resistor configuration as last time, and a lot of people speculated that this is probably for like physical hardware build differences for the optical inspection camera to see, oh, that a resistor's missing, and it knows what version of the board it's got. But I'm not sure if that's true, because there does seem to be some signal connections to them, and there's really only one board for this thing, because everything, including the 4-channel scope option, is a software upgrade. So yeah, I'm not sure what's doing there. It may be it is identifying the actual physical hardware version number, which is down here, version 1.01 perhaps. Now, unfortunately, we can't just take the board off, because all the BNC connectors and everything else are connected to here, and you can't just take the washers off the front, because there are no washers, so you have to undo all of the metalwork screws around here, take off all the knobs, and cross your fingers, they get them all off. Hopefully, there we go, ta-da! And I know a lot of people are keen to see what rotary encoders used in this thing. I don't know offhand. We'll have to look at the videotape for that one, because Rigol have had issues with the reliability of their rotary encoder pots before. So are they the same ones as the 1054Z? I don't know. Nothing hugely interesting under here. A couple of them are backlit here for the various channel colors and whatnot. And as soon as you get those nuts off, nothing like getting your nuts off. Let's, come on. No, I should have got some of the ribbons off. And annoyingly, to get those ribbons off, looks like you've got to unscrew the screen and then access through here, because they're connected on the back side of the board rather than through a slot and then on the top side. Urgh, bugger. And now, hopefully, it's all off. Ah, we're in. There we go. Bottom side, no, it didn't have all the additional memory. It's just got 2 additional memory chips there, and that's it. Nothing much doing on the bottom, but there's some extra analog front-end circuitry though. Well, looky what we have here. No wonder that they can sell a 2-channel scope with 4 channels in there for $909, because look, there's nothing at all in the front end. Pretty much, they got Rigol's new ASIC front end, of course, which has, you know, the programmable gain amp and the differential driver and everything else that's required. But it's just basically that ASIC, a couple of passives. We've got ourselves a, is that a MOSFET there? Yep, a MOSFET relay, and that's it. So if you compare that to the 7000 series, it's actually significant. Well, it's actually the identical layout around here. This all looks identical, the top end. The components on the back side of the ASIC there look identical. There's a couple of resistors down there, that looks identical. This has all changed because we've got an extra relay here on the 7000 and over here, and this PhotoMOS relay is switched around like that. But apart from that, oh, and it had, didn't it have 50 ohm termination on the 7000 as well? Of course, we don't expect 50 ohm termination on a, you know, sub $1,000 scope like this, so that's fine. But yeah, they've really pruned that down. So I'm thinking, have they, like, does it not do maybe some of the lower voltage? Maybe they've got like a digital amplification down at, you know, like a millivolt, 2 millivolts per division, something like that. There's nothing in these front ends. I wonder how much that ASIC costs them. Bugger all, the photo, probably, you know, maybe the PhotoMOS relay in there is more expensive than the ASIC, who knows? But yeah, it's just nuts. And if you think there's something more on the backside, nope, that's it. Just some extra passives and the heatsink in pad. That's all she wrote. But yeah, amazing. That's it. This is a 350 meg front end. There's nothing in it. Unbelievable. And I originally thought that the 7000 didn't have the heatsink, but it did. It was just didn't have the cutout on top here, so it was fully enclosed in the can. The cans were actually thicker, so both of them had the heatsink, but this one actually takes advantage of the airflow over the top here. It doesn't have to go under the sides of the shielding can. There is a gap. They don't necessarily sit all the way down. So yeah, this one's thermally, it's better. So maybe they realized the previous enclosed one wasn't that great, and they fixed it in this one. And one thing I don't think I noticed on the 7000 or any previous Rigol scope are these alignment pins like this that go into the PCB. So they use that for the alignment of the board rather than just rely on the, how you do an alignment of the screws on there. So it's rather interesting. They've got a few around on this design. Sunon maglev fan for those playing along at home. Well, I think that's a first. The shield on this power supply is actually soldered onto the board. What a bastard. Yep, caps on, or craps on as they call them. Yeah, sort of like bottom of the barrel electrolytic caps. Unbelievable. Like as I said, if you're paying the full $5,000 for this thing, you're getting craps on caps in your power supply. Oh, come on. But granted, this is not a $5,000 oscilloscope. This is a $900 retail oscilloscope that everything else is software optioned up. One of the good things is we can actually stand up the power supply and back panel like that and hack around, work on it while it's fully open. Nice. One of the most annoying things about this is the boot time. I'll get back to you. What they're trying to do is set a record. Bar graph got to the end, but way we're in 1:15. Kill me now. By the way, these are the probes that you get with it. The 500 meg jobbies apparently. So there you go. Well, that's the ones that came in my box anyway. So we'll just do some probing there. Probe that center pin of that little three-way jobby there and boot up. Bingo, we have data. All right, we can hook that up to our serial port, see what's what. And if you're wondering what's going, if you can hear something in the background, wave, Sagan.
Hi, I'm 42.
And there we go, we're in like Flynn. That's the boot code, which I'll post over on the EEVblog forum, as I always do, linked in down below. And looks like we're down to a root menu, root at Rigol. And as before, we got U-boot and Rigol-y dirty. Fantastic. Right, if you're curious to know what sort of temperatures we're getting, well, the ADC there, we're getting about 74, 75. The chips on the front end, 76, 79, sort of peaked at 79 there. Just the regulators next to it. So the ADC actually gets hotter than the Phoenix processor. The applications processor doesn't really get 55, doesn't really get that warm at all. A couple of other little random hotspots for the regulators and stuff like that. But yeah, of course, this is with absolutely no airflow whatsoever. So of course, you don't want that. So this is not realistic. Just wanted to show you the hotspots. And check it out. If I type in help, built-in commands, alias, change dir command, continue, echo, eval, exit, export, false. Look, check it out. We have all sorts of commands that we can potentially tap into. No, I couldn't, when it said press any key at the start, I couldn't get it to abort that boot process. Jobs? Nope. Test? Nope. Permission denied. So if you're wondering, yes, the third pin over there, that orange one, that is the transmit in. So, yep, transmit, receive, ground for the UART. Too easy. And it's hard to get fan noise on audio, but probably on par with the Rigol 1054Z, although this one's a little bit whinier, sort of like bearing whinier than the 1054 is like a more of a drone, but it's noticeable. In a quiet lab, it'd be pretty annoying. You'd want to change it out for a quieter one, definitely. Now, of course, one of the remarkable things about this, 100 meg points memory. It's very impressive, and 8 gig samples per second, which you get the 8 gig samples per second on the 70 megahertz model base unit. So it's absolute overkill, of course. You only need like 5 times oversampling, but if we have a look here, if we actually, so we're 8 gig sample with 100 meg points of memory, but we've only got the one channel enable. So let's switch on the second channel here, and bingo, we instantly drop down to a quarter of our memory, 25 meg points and 2 gig samples per second. But the good thing is that we'll keep our 2 gig samples per second even if we have all 4 channels enabled. So the 2 gig and 25 meg points there are for all the channels. And as with other scopes, it does actually matter which so if you had 2 channels, you want to use channel 1 and channel 3, for example, because that will gain you 4 gig samples instead of the 2 gig samples if you go with 1 and 2. So that's just the way that the sampling architecture works. Now, one of the most annoying things about this, I couldn't believe it was missing on the Rigol 7000, and it's missing here too. Whether or not it's in their new Phoenix chipset, I have no idea. But if we go into Acquire here, and then we have a look at your different modes, acquisition, normal, average, peak, where's your high res mode? Every scope on the market, even your couple of $100 ones, has a high res mode, a boxcar averaging mode to get your increased bits, you know, like effective 10 bits or whatever. It's just not there. And it's not there in the 7000 series, which is a $12,000 scope when you option it up or whatever. It's in that ballpark. This scope is a $5,000 scope if you got all the options, and they don't even have high res mode. It's ridiculous. Don't know what the hell's going on there, whether or not it was built into the Phoenix chipset and then they realized they couldn't do it. Crazy. And if you just plug in a USB stick, and by default, if you press quick like this, it'll save a PNG. Nice. And as for the screen on it, it's okay, but it's not the brightest thing out there. It's actually, the grayed out menus down here are very subdued, and even when you turn them on, it's not that bright. And we're looking down at a bit of an angle. If you put it straight on, it starts to, the graticule there starts to vanish, and at any sort of lower angle, it is really quite hopeless. So it's definitely not the best screen I've seen at all. And of course it is all touchy-feely, so we can call that up and then we can just scale through our... And of course you can do pinch and zoom and stuff like that. There you go. And we can drag the waveform. It's a little bit slow, but it's usable. And yes, the screen is very glary, so it's not terrific. And the volts per division, in case you're wondering, and let's go to 1 millivolt per division here, and there it is. And as you can see, it is pixel doubled. If we go to 2 millivolts per division, you can see that it's still pixel doubled. So we have to go to 5 millivolts per division before we actually get our true the front end signal level there. So you don't want to get this scope for any low level measurement. Tell you what, I don't mind the measurement menu here and like how it displays the stuff. Horizontal, vertical, like volts RMS, per period RMS, and you know, stuff like that. And nice little diagrammatic explanations right next to there. It's very nice. Unfortunately, one silly little quirk is that you can't actually see the thing that you want before it actually adds it. If we wonder, oh, what's per VRMS, for example, you click on it and it's automatically added it down the bottom. So, like, yeah, okay, it's nice once you know, but when you're trying to learn these things, then it just automatically adds it. And look, it doesn't actually add it as a physically separate thing. It sort of like expands that window. That's interesting. Not sure if I like that or not. Delays in other, that's nice. And analyze, sweet. And it is supposed to have a hardware frequency counter as well, some high resolution thing. Haven't tried it yet. And then their interface isn't quite consistent. Like if we go to turn on the signal gen, for example, I can barely tell that's on because it hasn't done the box around there in yellow like it did the box around here in yellow. So you hardly even notice it. Anyway, here's all our stuff. It's pretty comprehensive. It goes even further than that. It does ARBs as well. So, you know, it's not too shabby. Maximum amplitude. Let's go all the way with LBJ. No, there we go, 5 volts maximum amplitude. You can use the keypad because this is all touchy-feely. So let's go to, say, 9 volts there, like that. Over upper, obviously. And you'll notice that it's actually in stop mode, so we're not updating, but the hardware frequency counter will still update. Look at that, nice. And yes, we can do modulation on the generator as well. So different types of AM, FM, FSK. That's all right. So what does our intensity grading look like? Well, we've got our standard 1 megahertz sine wave test signal with 1 kilohertz 100% modulation. It triggers on it very, very nicely. So let's see if we can alias on that. Of course, we've got 20 meg points, which is a lot of memory. So I don't think we're going to have an issue there. Oh yeah, there we go. We're starting to do it now. Starting to do it. No, doesn't like that at all. Oh, hang on. What have I done? It's locked up. Ah, what? The scope is locked up. Well, there you go. People wanted to know about the quality of the firmware. At this particular stage, of course. I swear I can't do anything. I can't run, stop, single. It is completely locked up by just changing the time base down. It might have maybe tried to go into like auto roll mode or something. Ah, what? Seriously, I can't do a thing. I can't turn my generator on and off. I can't, wow, that's the first time I've seen a scope completely lock up, I think. No, you can't even get back with the default button. Wah, 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 wah. All right, so I rebooted and I just thought for a second that it was this time base. Look at this. It can go to 100 kiloseconds. That's insane. But it's not that. It should actually recover from that. No worries whatsoever. So it's interesting that the modulation has vanished. The generator, when it rebooted, the generator is still on by default, but the modulation is not. Do our modulation again. 1 kilohertz AM. Oh, that looks horrid, doesn't it? What's going on there? That's not my 100% AM. Oh, have we got the frequency wrong? Hang on. Yeah, yeah, our frequency is 1 kilohertz. So we need to change that. 1 meg, there we go. Okay, we're in like Flynn again. Can we recreate the magic? No. So yeah, I'm not sure what caused that lockup. Anyway, intensity graded display. That was annoying. I went to use that as the intensity control, like we had a function selected. So unfortunately, now there we go, that's better. That's nice. Rigol always have good intensity graded displays. That one looks pretty schmick. I like that. You can see like the broader color in there and the more faded color. It's very analog oscilloscope like. It's not smooth. It sort of like jumps around. I mean, if we go vertical like that, it actually, every time we move it, it actually stops sampling completely. So yeah, it's not the most responsive and smoothest thing on the market, but it's okay. It's usable. I'm just not going to write home to my mum about it. All right, I don't want this to turn into a full review, so let me know how you want to see this thing. Do you want me to compare it to the Siglent 2000X, for example, which is probably its main competitor at the price point? We could see it against like the Rohde & Schwarz 2000, but it's more expensive as like a base unit. But up in the high end, this thing is actually really expensive and doesn't seem to compete as well, bang per buck, once you start upping the bandwidth and upping the options. Logic analyzer here, there we go, we've got all 16 channels there. Let's check out where we can get our threshold. Yep, it has group-based threshold. There you go, or you could have user, so that's nice. Small, medium, wow, small is really small. Anyway, let's go to serial decoding here, and the serial decoding is quite expensive. I don't know why they don't just throw in like an RS-232 decode or something like that. Anyway, we do have 4 different decoders here. So if we turn on RS-232, check this out, can go all the way to 20 meg baud. Wow, that's pretty impressive if it can do that for those fast serial bus fanboys. Display, we can do event tables and jazz like that. View individual packets, details, payload. That's pretty jazzy. Don't mind that at all. Just the serial decoders you could do like a separate video on. Types, of course, they're all optional extra, which is absolutely ridiculous. Can we actually use the digital input? Are we forced to use the digital inputs, or can we use the analogs? Yep, we can use the analogs. There you go. So in theory, we could have our 16 channel logic analyzer and serial decoding happening on our analog channels as well. So that's pretty jazzy. Let's go to SPI. Okay, it's got timeout mode. That's nice so that you don't need the extra line there. You don't have to dedicate that. Once again, selectable threshold level and kilovolts. Yeah, nanovolts. Yeah, that's what I need. Nanovolts threshold level for my SPI bus. Yeah, once again, the sources, analog and digital, for it looks like for any of the serial decoding. So that looks pretty jazzy. Once again, you can get event tables, view payload. Sorry, I'm not going to bother actually doing real serial decoding with this. I'll leave that for another video. And it does have lots of cool features you can access from the main menu here. It does histogramming, it's got a hardware frequency count, it's got pass-fail mask testing, you can draw rectangles around stuff, it's got zone triggering, it's got power analysis, that's an optional extra stuff. It does have 1 meg point FFT. So for those wondering about the FFT capability, and previously on the Rigol it's been crap, but the new one, 1 meg point. I won't go into details, but yeah, it's suffice to say it's better than previous Rigols. Anyway, that's a teardown and preview of the new Rigol MSO5000 series, and I am stunned that they came out with this so quickly after the 7000 series. It's just, it's nuts. Now, at $909 US, for all the you get all the hardware. There is an impressive amount of hardware in this. Yeah, it's got some limitations, but for $909, if this thing is hackable, they will not be able to manufacture enough of them to keep up with demand, because it'd be insane if it was. Now, the value proposition for this thing, I'd have to go into the details, but it's not hugely competitive at the high end. So yeah, I don't see them selling many of the $5,000 ones of this. You know, like, you just don't, you know, simple stuff like the probe interface and stuff like that. It's just like, no, you're not going to pay that sort of money and live with those sort of limitations. Forget it. So I'll try and include here just some basic price differentiators at different levels with the basic competition for this 5000 series scope, and let me know what you want to see in terms of like a review. I don't have this one for much longer, like I think maybe an extra week I might have it, so let me know what you want to see. The main competitor is probably the Siglent at the low end. At the higher end, it's like, you know, the Keysight and the Roden Schwartz, and I don't know about the tech. So anyway, let me know what you think in the comments down below, and as always, I'll link to the forum thread where I've got all the data dump from this thing, and I'm sure people will be trying to hack this thing. I mean, at $909, whoa, wow. You know, if you could hack that 350, even if you couldn't get the bandwidth, even if you could just get like all the serial, you know, all the serial decoding options and stuff like that. And this is where Rigol, you know, they might eventually, if it's not selling, they might decide, oh, let's, you know, special, let's bundle in all the decoders and stuff like that. I'm not sure what's happening with the logic analyzer probes or why I didn't get them, which is kind of silly. And I think you might actually have to buy the probes extra, even though it's the MSO model and there is no DSO model. It's only the MSO model, but I think you might have to actually buy the probes extra, even though it says MSO on here, which is just like crazy if that's the case. Anyway, links down below, and if you like the video, please give it a big thumbs up, because that always helps a lot. And I've got some other videos here at the end. Check them out, and as always, subscribe. That little notification icon, little bell icon, you've got to turn it on. Otherwise you won't get my video notifications. Catch you next time.